Sometimes we see equations with multiple variables within. We see one variable expressed in terms of another. Today, we are delving into a topic that introduces a new level of flexibility and power: literal equations. Let's start. Let's start literal equations. So what is the meaning of a literal equation? An equation that has two or more variables is called a literal equation. So we'll see equations that has more than one variable, and the objective over here is to solve for one variable in terms of the other variables or terms. Now the strategy here stays the same, just like we did for other equation solving process. We'll see a couple of examples over here. So let's see, we have an example of A equals L times W. So this operation between L and W is multiplication. You can see a dot over here. This is the multiplication operation. We oftentimes use dot to represent multiplication. Now the objective over here is to solve for L. Now how do you actually solve for this variable L in terms of the other variables? We can see that the operation over here is multiplication. So we need to do the inverse operation of this multiplication. So we divide both sides by W. Once we do that, this W cancel each other out. So we have L equals A over W. This is basically how we isolate one variable in terms of the other variables. We'll see a couple of more examples. Let's say we want to solve for W. How can you do that? Let's try this one. So again, the operation between L and W is multiplication. This time we want to isolate W. So we want to divide both sides by L. Once we do that, we have W equals A over L. So you can see the explanation over here that the operation is multiplication and the inverse operation of multiplication is division. In both cases, we just have to divide to isolate the desired variable. Now let's look at this example. We have P equals 2L plus 2W, and we want to solve for L. By the way, this is a formula for the perimeter of a rectangle. We use this typically in geometry or in word problems. Okay, now let's see how we can solve for L. So first we see that we need to move this 2W, and also we need to get rid of this 2. Whenever we have any extra terms outside of the desired variable, we remove that first using addition or subtraction operation. In this case, we can get rid of this 2W from the right side by subtraction, because the operation between this 2L and 2W is addition. So we want to get rid of this 2W by subtraction. So we subtract both sides by 2W. Once we do that, this one cancel out, and we have 2L equals P minus 2W. P minus 2W equals 2L. It's same in either way. Now that we have 2L isolated, we can get rid of this 2 using division, because 2L means 2 times L. We simply divide by 2 on both sides. Once we do that, these 2 cancel out. We have P minus 2W over 2 equals L. This is how we isolate the variable L over here. So here is the quick strategy. If you want to remove any whole term, we can use subtraction or addition, just like we did over here. If you look back, we had to remove this whole term, so we had to use subtraction. And if you want to remove any partial term, we can use multiplication or division. Just like over here, we can see that we had to remove these 2 from L. This is the partial term, and we had to use division. So keep these 2 strategies in mind when solving for problems like this. Now let's try to solve this problem. Over here, we have 3y plus 4x equals 9, and we need to solve for y. So the first step, we can write down the equation. Now we know that this 4x is the whole term and this 3 is the partial term. So we can get rid of this whole term 4x by subtraction. So you subtract 4x from both sides. Once we subtract and simplify, we can see that 4x cancel out. We have 3y equals 9 minus 4x. Now you can get rid of this 3. The 3 and y are in multiplied form, so you can use division property to remove 3 from the left side. Once we divide by 3, these 3 cancel out. We have y equals 3 minus 4 over 3x. We can see that this 3 is distributed to both 9 and 4x. So it's 9 over 3 minus 4 over 3x. So this 9 over 3 simplifies to 3, and 4 over 3x does not simplify anymore. So our equation for y is 3 minus 4 over 3x. Okay, so the problem statement says solve each equation for the indicated variable. Number 1, we have u equals kx minus y. Now we need to solve for x. So here we have these strategies. If you need to remove the whole term, we can use addition or subtraction. And if you need to remove the partial term, we just use multiplication or division. So if you need to remove this k from x, that's a partial term. And if you need to remove this y, that's a whole term. Here I just need to remove this k and y so that I have this x isolated. So first I just remove this whole term y, and I have to use addition or subtraction. In this case, we have a minus sign in front of y. So just add y on both sides. If we add y on both sides, we have u plus y equals kx. Now you can see that we need to remove this k, and this is the partial term. So we have to use multiplication or division. Now this is k times x, because kx, it means k times x. So just divide by k on both sides, and that cancels out this k. So we have x equals u plus y over k. Let's look at this second problem right here. Here I need to find my a here. So we have z equals m minus a minus b. Now we need to remove this m, and we need to remove this b. All these are whole terms, so I have to use addition subtraction. Remember, the partial term belongs to the variable. So if there is any letter or number with respect to the selected variable, which is a, that is the partial term. So in this case, we have z equals m minus a minus b. So since m and b are whole terms, let's try to remove them step by step. So first, let's try to remove this b. Now the sign in front of b is minus, so I just use plus. See, if I do add, I get z plus b equals m minus a. Now I need to remove this m. Remember, we have to isolate the variable a. So to remove m, the sign in front of m is a plus sign. So we use subtraction. If we subtract, we get z plus b minus m equals, now we have this minus sign in front of a, so that will turn into negative a. Now to isolate any variable, we need to make sure that the coefficient in front of the variable is 1. So we have this negative sign here, that basically means it's negative 1. So you divide both sides by negative 1 here. Now if I divide everything by negative 1, the sign in front of each letter would reverse. So I have negative z minus b plus m equals a. We can rewrite this with having the positive term first. So you can write this as m minus z minus b equals a. That's how we isolate this variable a. In this third problem, we have k over a equals w minus v. And we can see that we need to isolate this variable a, which is right in the denominator. Now this gets a little tricky when you have to isolate a variable from the denominator. Anytime if you have any variable right in the denominator, we just treat both sides of the equation as a fraction. So we can write k over a. I can also turn this into a fraction. Now this is a whole term, w minus v. I can make this as a fraction by taking 1 at the denominator. So I can write this as w over 1 minus v over 1. And then I can combine this denominator into one denominator, which is w minus v over 1. So you can do this over here. So if we do that, we get k over a equals w minus v over 1. Now we need to do cross multiplication. So here is the shortcut trick. Whenever you have any variable at the denominator, to isolate that variable, we do the cross multiplication. So now we have a times w minus v equals k times 1, that is k. Now you can see that we have a times w minus v, and we just need to get this a isolated. So I just divide by these w minus v at the same time. W minus v is now a single term because it's within the parentheses. So you divide by w minus v and we get a equals k over w minus v. This is how we solve this variable a. Again, when the selected variable is in the denominator, we just take a fraction on both sides and then do the cross multiplication. And if there is no fraction, we can just take 1 as the denominator. Let's look at number 4 right here. For number 4, we have u equals y plus x times k. Here we need to isolate this variable x. So first we get rid of this whole term y. So we subtract y from both sides. Y subtraction because there is a positive sign right in front of y. So now we have u minus y equals xk. Now since we need to isolate this x, I need to get rid of this k. Now the operation between x and k is multiplication. Now remember that we can use a commutative property. Here we can write this x times k as k times x. So it does not matter how we write this product together. So now we need to get rid of this k. So just divide by k on both sides. We have u minus y over k equals x. Let's look at this fifth problem right here. We have g equals y minus xc. So we need to isolate this variable x. So first get rid of this y. The sign in front of y is a plus sign. So we subtract y from both sides. Once we subtract y, we have g minus y equals, now we have this minus sign, so that would be negative xc. Now first we can get rid of this c by the division. If we divide both sides by c, we get g minus y over c. Once we divide by c, we get g minus y over c equals negative x. Now we know that this negative sign represents negative 1, and we need to get rid of this negative 1 by simply doing the division by negative 1. So if we divide both sides by -1, we can see that this is g minus y over -1c. So let's try to simplify. -1 cancels out here. We have x. So this g minus y divided by -1c, we can write this as this negative sign, g minus y over c. And we can also do the distributions of this negative sign. If we do distribute, we get minus g plus y. The negative sign and this plus g would be negative g, and this negative sign with this minus sign would be plus y over c equals x. Both are correct. We can also rewrite these as y minus g over c equals x. You can see that we can write in all three possible ways. So you can write like this, or like this. So that's how we solve this problem. And that's it. And there you have it, the introduction to the world of literal equations. We navigated through the introduction to literal equations, defining their purpose, solving for specific variables, and expressing relationships. Keep practicing this topic, and if you have any questions, please post it in the student community. That's it for this video, and I'll see you in the next one. Now let's get to study.